Hi, Jakob. Welcome to the show.
Hi, thank you.
What was your first computer?
My first computer was a Commodore 128,
Okay.
but
Wow.
I mostly used it in Commodore 64 mode because we were just kids, so we mostly used it for gaming, right, for playing games.
Were there no games for 128?
There were, but not as many.
Okay.
Not as many as for the C64. So it was a bit hard to get the 128 games.
I watched a game, the Commodore 128, and it was something with martial arts in Japan. And this looked actually amazing. This is what I remember. I forgot the name, but this was actually a great name. So I just wanted, to see. I'd never had a Commodore 128, but yeah, I watched a game. I remember until now, and it was amazing for that time.
Yeah, I remember. Was it International Karate, and then there was the Way of the Exploding Fist.
Something like this, I guess. So where you walked, through beautiful landscapes and then something. Uh-huh.
I think that was maybe The Last Ninja, probably.
Yeah, I think so. So you are expert, I see already. So when you stopped actually playing and started, do something different than games?
I think I started programming, I think, about a year after. So after we got the computer. But back then it was mostly basic. And as far as I remember, the Commodore 128 had some kind of graphics capabilities built into this basic language and also sound. So it was possible to draw graphics on the screen and also to play sounds through the programming language. So I spent some time doing that, and I remember my big brother also spent some time doing that as well. But he's not working with computers today right now.
Okay, but why you stopped gaming and started, with that?
I guess I was fascinated by the ability to control the computer. I guess maybe one day create my own games or something like that. But at that time there were too many things I did not know how to do. So most of my programs would run and they would be completely without any input from the outside world. So very predictable and therefore a little bit boring.
Okay, so what was the highest achievement back then? Basic 128 Commodore programming achievement. So, the most cool, the coolest, or the most complicated piece of software you wrote on the Commodore.
I think on that one, I think just some of these graphics programs that were drawing graphics on the screen.
Yeah.
So nothing too advanced.
What happened then?
Then after that, the Commodore Amiga 500 was released, and of course, at some point, I had to get that one. And once I had the Amiga 500, at some point, of course, I started with the games, and at some point, I also started seeing these demos. And so, of course, after some time, I got completely sucked into trying to do demo programming. So I wanted to learn assembly language instead of Amiga Basic in order to control the computer more. So I spent a lot of time with that. I also managed to program some simple graphical effects that such as scroll text and sinus scroll text and like some kind of like zoom and blurring effects and simple 3D graphics as well. But at that point I was not able to put it together into like a coherent demo. So I was still missing some tools for like structuring a big application or something like that, and also with these bootloaders and all that stuff.
So demos were more or less like movies, right?
Yeah, they were like like a computer music video, where just programmers showing off their skills.
Okay. And how much time you spend with it? So like
That's a good question.
Because it interests me, how persistent you were back then, just to achieve something interesting.
Well, persistent enough to do that over some years, and I guess I was maybe spending some hours at least some hours every week, just programming and trying to learn how the computer was designed inside, and
Cool.
with the Amiga, you also had to program the graphics chips. So that was like you write some numbers into a specific address, and then you would write into like 3 or 4 or 5 or 6 addresses. I cannot remember how many. And then I think when you wrote into the last of these addresses, then that would trigger the graphics chips to start doing something.
Sounds like, fun, because if you provide, the wrong addresses, nothing will happen, or the computer will crash. I can imagine.
We had a lot of. I programmed also with some friends, but we had a lot of crashes where the computer would just completely stop functioning, and you would have to reboot the computer. Right? At the time, the assembly language editors that we were using, they would keep the assembly language directly in memory. So if you forgot to save it to disk, and you would execute it and it crashed the computer, then your program was lost. So that was a little bit.
So I had that ZX Spectrum, but I also enjoyed saving. So save to tape, the basic, and this was surprisingly fast because it was just a little bit of text. So a game loading was a completely different dimension. Interesting. So this was, I think, 68,000, right? This was the assembly you used.
68,000, yeah.
Incredible.
Motorola.
How old were you back then? Or young?
I was a teenager.
Okay.
Probably it was around 15 or so. 15, 16, 17.
Okay. Not bad for assembler.
18, and then I started, and then at some point, the PCs, they started becoming so fast that it got a little bit boring to keep programming on the Amiga 500.
So you switched from Amiga 500 directly to a PC?
I did that once I started studying. I started studying computer science, and then I needed a computer to do all the programming homework on. And at that time, it was most of the courses would use Pascal, and for that I didn't need a PC, but it was obvious or easiest to just get a PC and get Ball and Pascal installed, and then I could do my homework.
You enjoyed Pascal?
It was okay. It reminded me of BASIC, right? So it was very similar to BASIC, I think.
But I think Pascal had already functions, right? Or methods. The BASIC, there was just go to and go sub, at least in my BASIC.
That's true. So Pascal had functions, and it had the limitation that the functions had to be defined earlier than when you called them. Yeah. So you had to define all your functions at the top of the program, and then you had to have the main part of your program at the bottom of the source code. And I think in later versions of Pascal, or at least the Ball and Pascal that we had, it was actually possible to switch to assembly language inline, to just do inline assembly language. Yeah,
not bad.
So at that point, then I started studying PC assembly language, and then I also did some graphical effects with that.
But I have no experience. I had a little bit experience with 68,000, but not with Intel assembly. But what I was told is that the Intel assembly is not as beautiful as the 68,000.
No, and I think one of the reasons for that is the register layout of the Intel chips. So you would need, wherein in the 68,000 you had 32-bit registers, and in the Intel chips you had only 16-bit registers at the time. So you had to combine 2 registers to get a 32-bit reference. And so at the time, once you needed to address memory and all that stuff, the addresses, because you had, of course, more than 64 kilobytes of memory in a PC, then you would need to combine 2 registers to create a full address.
Okay.
So that was a little bit more clumsy in some ways. But I haven't done a lot of assembly in a long time, so I don't know what it's like today.
And why you did it still was the demo scene. You wanted to create another movie.
It was still the demo scene, and that was what I thought was fun. And then also, as part of that, I developed this interest in optimizing code. Because, of course, the faster you can get your code to run, the more smooth your graphical effects can run. Like the more frames per second you can have. And that kind of stuck with me until today. I still like to optimize code today.
Okay, so I'm the opposite. I like to optimize code if it makes sense. Otherwise, I don't care. No, it's fast enough. It's like, okay, simple first, and then if it doesn't work, then I would like to optimize. It seems like we would have together fun in a project. There will be constant, fight between simple suboptimal code and fast code.
Yeah, I think that is it's a difficult. I think I don't know if it's a debate or discussion, but in some ways it seems like many of the I think was it Martin Thompson that said that many of the advances made by the hardware have been nullified by slower software.
Yeah,
And
yeah.
I've seen that argument also in I think one video on YouTube. It's called the 30 million line problem, saying that hardware is actually incredibly fast, but we make it very slow with bloated operating systems and bloated frameworks and bad programming practices and all that stuff because we think it's fast enough now. But it's true, it is fast enough, right? So it's fast enough for many things. So I think that it's difficult to find out should you try to make it even faster or not. I mean, then you can run more on the same PC, but if you don't need to run anymore, then maybe it's a waste of time.
No, for sure. You can save a lot of time. So if you go to the cloud and you optimize your code, you will pay less. So the first time in the history, you can actually show that optimized code saves money.
Because if you already purchased the server and it's going to take the power it takes, regardless of how fast your application is, and you don't run any other applications on the same hardware, then you're not getting any benefit out of optimizing.
Or even worse, or even better. In serverless world, you get you are paying for gigabyte second all the time, so you actually see per call how much you are saving or wasting. Yeah, cool. So you switch to Pascal and then you optimize Pascal.
Yeah, Pascal, and then some assembly language, and also C. I started programming C at the time.
Okay.
We mostly did that. I mostly did that in my spare time because we did not use C that much during the education.
Where you studied? In which town?
I studied. It's called Roskilde, so it's not a very big town in Denmark. And
okay.
They have a university center there. Then I studied there for my bachelor in computer science, and then I was out working for 4 years, and then I switched to another university in Copenhagen.
Oh, mm-hmm.
It was a newly opened university at the time, so it's the IT University of Copenhagen. So it's mostly focused on IT stuff, and so software development, but also like application design and interaction design and all these kinds of things. So
okay, nice. So you started to Pascal C. What happened then? C++, I assume.
No, what happened then was Java was released.
Okay.
The first versions of Java, and our university was among one of the first ones to switch to have part of the education or the computer science education in Java. So then I switched to programming Java, and after that, then I started in my first job. That was in a web company back in '98.
Wow!
So that was a lot of. I had to learn active server pages and Visual Basic script, and I had to learn Perl, and we also did a little bit of Oracle PLSQL.
Okay.
These kind of scripting languages back then.
But PLSQL was not as bad. Did also a little bit of that back in the time. But what was your impression of Java after your experience with C, or Pascal on assembly? I mean, it's a completely different world.
I liked the object-oriented style of programming because during one of the courses in university, we had a small course in object-oriented programming, and I think we were using some kind of object-oriented Pascal. It was not Delphi, but it was something similar to that. Mm-hmm. So some kind of object-oriented Pascal, and we made a small adventure game, but it was just a text adventure game. You could walk from room to room, and then you had a few actions available in each room, and you could drop and take items. Mm-hmm. And I really like this object-oriented way of designing an application. So after I got used to that or got into that in Java, I was hooked to that way of designing applications.
So interesting.
I didn't go back to C. I could have maybe gone to C++, but I don't know. I think at the time I was probably, once I started working, I had 1 year in this web company, and then after that I started working with Java full time. And then I think since then I spent most of my time just trying to catch up with all the features in Java.
Yeah, this is also my story, but this catch up with Java. And so I assume,
patterns, right?
yeah, you started with JDK 1.0, I think, at the university, because
Yeah,
yeah,
I think so too.
it's incredible. How it was interesting how the university knew about Java. I mean, because that there should be some relation between Sun and the university, because JDK 1.0 was unknown actually.
Yeah, that's a good question, because we had books in the books. We had the books in our in the local bookstore there on the university. We
Java
had
in a
Java
nutshell.
books. Yeah, no, I think it was the Java books, probably Java in a nutshell as well. But I think it was. I remember the ones from Sun themselves. They had this series called From the Source.
Yeah,
and I remember those because they had these some kind of they had a nicely designed front.
yeah, exactly. So it was white books.
White books and
yeah.
some kind of
silver or something, right?
Yeah,
it was like
exactly.
yeah. And the Java in a nutshell was by David Flanagan back then. I remember. I think I never met the guy. Interesting. He wrote one of the first books. Mm-hmm. Interesting, because you spend lots of time with assembly and C and still like Java. Usually people who are down to metal, they don't like object-oriented programming because they say, that is waste of resources. And you are the huge optimizer, and you still like, object-oriented programming.
Yeah, I do. I think I started picking up some of the tricks from Martin Thompson back in, I think, 2011.
Mm-hmm.
Instead of just having objects spread out all over memory, you would just have the binary data stored sequentially for all these objects in large arrays, and then you could scan over them very, very fast.
Mm-hmm.
And you can still, even though the data in your application, that data that is represented or stored in these arrays, even though they are not represented using objects, the rest of your application can still be designed using object-oriented techniques.
Mm-hmm.
You just need to maybe make some exceptions or deviate from that once for the big amounts of data that you need to process.
Mm-hmm.
But configuration objects and like file loaders and all that stuff, you can still use object-oriented techniques to get some kind of decent design, I think.
Mm-hmm. And why you did it? For fun, or was it a need, or was it a specific project where you had the requirements?
I mean the performance.
Mm-hmm. This, the idea that you are storing everything in an array.
No, of course not. I think at the time, I wonder what was happening at the time. I think I was still very much interested in performance tuning and trying to get as much out of a single server as possible at the time, even though I was at the time also aware that it did not make a whole lot of sense because of what we just talked about earlier, that you would anyways typically only run one application per server.
Mm-hmm. So what were your projects? So after your Visual Basic enjoyment, so you were back to Java. So which project you spent your time? Was it like enterprise project, or what technologies? What you used?
Yeah, mostly enterprise type of projects. In my first Java role, the company that I worked for used the SIlverStream application.
Okay.
And that was before Java Enterprise Edition was standardized.
Mm-hmm.
So it was actually quite advanced. It came completely with its own development environment. So it had its own IDE built in,
mm-hmm.
and it came shipping with, I think it was Sybase database.
Mm-hmm.
So that once you would run your application server, and then you would automatically get a Sybase database running as well,
mm-hmm.
and then it would store your applications inside the database as well. That was a little bit of a neat trick, but apparently that made it easy to
version
to work. to work multiple people on the same application, and also to copy applications from one server to another, just copy the entire database, I think.
I remember actually SIlverStream. Which company was it? Was it SIlverStream and SIlverStream?
That I worked for?
No, yeah, the application server. No, which company created the SIlverStream?
I think it was called SIlverStream at the time, and
Okay.
then I think at some point, I am not sure if it was Sybase that bought SIlverStream, but it was acquired by another company. Or maybe it was the same company that was making Power Builder.
This could be.
I'm not sure, because it was very similar in design to Power Builder.
It was bought by Novell, seems like, because I found now Novell tutorial about SIlverStream.
Ah, okay, yeah.
Interesting.
That sounds kind of right.
And this tutorial goes with com SSW was the package structure, and the tutorial is about Java EE version 2. So this was after your time, but interesting.
Yeah.
This is actually one of the reasons why I really appreciate Java EE, because there were lots of application servers and they couldn't understand them. They were so different. And if J2E came out, so for me it was huge. So okay, cool. Now I learned the API and I don't care about the implementation. So this was huge news for me. And back then it was impossible. So SIlverStream, persistence power tier. Then there was Borland application server, Tenga from WebLogic, there were WebSphere, and lots of servers.
Yeah, and there were also some that I think were acquired, and then kind of erased.
Yeah. Orion server from Sweden.
There was something called Web Objects also.
Yeah, this was from Apple. And the interesting part with Web Object, I was a Java 1, and Apple announced that the Web Object application server written in Java prior to Java 1 cost 50,000 K. This I remember exactly. And during the Java 1, it cost just 500 euros. And the cool story is, years later, I still found some developers who really like the Web Objects from Apple.
How about there was also this Cold Fusion, but that was also very different, right?
Yeah, this Cold Fusion was, I think, different. Maybe I think it was Web Object from Apple, and Cold Fusion was like, a scripting included. So this was like competitor to servlets. I don't think this Cold Fusion had something to do with Java. They had their own language. Interesting. I didn't know actually that you also did enterprise. I thought you are just a Java guy, because I found you on Twitter and I know your tutorials from time to time. I find your tutorials is a huge amount of resource actually about Java. And recently you wrote something on Twitter and it appeared on my timeline. It's like, we have to talk, because I don't think I met you somewhere. And it's always fun, This is my podcast, the opportunity to misuse podcast to meet people.
Yeah. No, it was nice. I think I have seen you in my Twitter timeline from time to time. I think I have also seen your name. You have been speaking at various conferences also.
Yeah.
And I have probably seen some of your presentations as well, because your name was known to me. I kind of had an idea who you were already when you wrote me on Twitter.
Hey, cool.
I have also seen your YouTube channel as well.
Oh, thank you. So what happened after the SIlverStream? So what interests me, your path. So what were your projects, where you spend your time, and what you do with Java?
After SIlverStream, I was.
Oh, excuse me. What you built with SIlverStream? Maybe was it like e-commerce app, or what was it?
The first one of the systems I had working on was like a case management system for the tax court. So not the tax authorities themselves, but in case you complain about your taxes, it goes to a special tax court. And they needed a system to manage all these cases that they had to adjudicate. And so that was one thing. And another thing I did with SIlverStream I helped doing was a logistics system, a system for UPS.
Oh, okay.
That was in the UK. And I think that after that, I cannot actually remember what more I did with that. I think after that, the consulting company I worked for was acquired, and then they also had a Microsoft department, and then they kind of down prioritized selling Java consultants a little bit at the time. So then at some point I just switched to being a freelance consultant, and that was around year 2000, and then I started just working for larger financial organizations, and that was mostly with either WebSphere or WebLogic or Tomcat. Usually these. There were some of them. A few of them were using JBoss at the time, but
in Denmark, this was your.
That was in Denmark. Yeah. That was still in Denmark.
So you are a freelancer since 2000.
I actually last year I changed that. Yeah, what I was a freelancer from 2000 to 2021, mostly. But I am now. I am working a lot with the AWS architecture.
Okay.
So, and in order to learn that and learn that, also have some colleagues that know a lot, and also just to have colleagues in general. It got a little bit boring in the end with all the freelance work.
Okay.
Then I'm actually now have a permanent employment, or permanent, or what do you call it, just a regular job as a solution architect.
Solution architect. Yeah, what's funny, the term solution architect appeared maybe in the last 3 years. Back then, it was just architect, right? So if I hear a solution architect, I always thinking there has to also be a problem architect, rather than why solution without problems. And I ask Twitter, like, why you call yourself solution? Because I never heard this. And they say, okay, and someone tried to explain me the difference between architect and solution architect. But so are we solution architects? Or what's the difference? Because we a long time we were just architects from projects.
I have tried to make sense of all these different architect titles as well. I guess the general term, or like the umbrella term, would be like IT architect.
Okay.
And then I think as far as I have experienced, the enterprise architects are mostly working, at very high level, so they're not super technical. I mean, they can be technical. They can have a technical background, but their work is not so technical. It's mostly looking across all the systems in the entire enterprise and seeing how do we get this system that we are now buying from vendor A. How do we get that to integrate with our single sign-on and this other system that we bought from vendor B? So it's like all the big lines. And then I think solution architect mostly is like it's like a step below that. So you are focused on like a single solution within the enterprise, but not the entire enterprise landscape or IT landscape. And I think a solution architect role is probably also more of a design role and less technical. But I mean, in KeyCore, we are very much hands-on with AWS, but I think many solution architects are still work mostly at a specification level.
Okay.
And then I think we get down to the software or system architects. That's when it starts getting technical. You need to really understand what's going on there in order to design the architecture. But I mean, we can have a ton of layers of these architects.
But the solution architect is new. It never appeared before. So I was curious why now, right? Because it was never there was never such a term. And I remember back then, as the architecture started, we made the distinction between architect and designer. And the architect was the person who, had to say, okay, this is my idea, this systems communicate in this way. And the designer provided, the design of the system, showed the architect how to do this. So for me, it sounds like the system architect and solution architects are more designer. So I think I never was an enterprise architect then. Also, I called myself enterprise architect. So it is like the first few hours I was enterprise architect, then solution architect, and then next day, usually, the system architect, because we always had to code a little bit. So, cool.
I think actually, in my experience, the best solutions usually come from the architects that are able to understand the system.
Yeah.
In all its layers, right?
Yeah.
Even down to the hardware, but and also up to understanding, all the way up to the business, understand what's going on and what direction the business is going in. Of course, you cannot understand everything perfectly, but if you have like a good foundational understanding in each of these layers, then usually the solutions seem to make more sense to me, at least.
Okay. So now, why you have so many tutorials on the webpage? And by the way, you redesigned your webpage, I think, right? So it looked a little bit differently.
It did. Why I have so many tutorials? I remember, I think I've always wanted to run my own company at some point, I think. And that is one of the reasons I started as a freelancer. And then at some point in the early days of the internet, I started listening to all these different voices in the startup space. When I think that once, web startups were popular already, from probably a few years after the .com crash. They started getting popular again. I think in the beginning, I did not feel confident enough in my programming skills to be able to do that. But then later on, the people like, what is his name? Jason Calacanis and I can't remember the other name. Anyways, they started talking a lot about this, and I thought, okay, well, talk about content creation as a business. And I thought, okay, what kind of content can I write? And then I started looking around, and when I realized, well, I know how to program, so maybe I can start writing a blog and see what comes out of that.
And what happened?
Well, a lot of things happened over the years. The blog grew reasonably popular. It's not as popular anymore because there's so many competing tech blogs today. So, but at the time when it peaked, I had around 1.6 million page views per month.
Okay.
And so people were happy to read that. I think what I tried to do different from the other blogs at the time was that I tried to make them a lot more concise and yet go into more details than many of the other blogs. And so the way I try to make them concise is by cutting out the introduction. At the time, many of the articles on the popular websites, such as the server side, they would start with like 2, 3, 4 paragraphs of just, if you are in this situation, then this might be interesting, and then that might be interesting. And then at, 2, 3 sections down, they get to what they actually want to talk about. And I would usually just cut that away and just skip directly to, if you need to use Java collections, then it consists of the following constructs, just directly to it. So that was what I tried to do different at the time. And then as the traffic grew, I started putting Google Ads on it and see, if I could make it a business. But at the same time, as I got a lot of competitors. Then the ad space online also kind of collapsed, and you can see many of the newspapers today. They have a hard time making any money from online advertising, and so.
But you could earn some money with the ad space. You could earn something.
I did. Yeah, I did earn something. I did earn something. There was a time I did spend some time full-time trying to make a living from this. And at some point I was just below breaking even, right? I could just barely pay my expenses, but at a salary that would maybe be the same you would get in a supermarket, right? So very low salary.
Yeah.
But then it started going down again from there. And at some point, I think I spent another 2 years or so fighting, trying to get it back up. But at some point I had to just give up and go back to work normally again.
Okay.
So that's why I have that many tutorials, is because I tried to make it a business at some point. But
what I remembered right now, because you mentioned at the beginning an array of objects, and the entire time, in my background thread, I was thought, I know it from somewhere. I think you remember the disruptor pattern?
Yeah.
So this was like a ring of byte arrays, and you could actually allocate new memory. And you also use that?
I did not use it directly, but I studied it a lot. And I think one of Martin Thompson's presentations that mention the disruptor pattern also mentions these the time differences between when you access memory sequentially and if you access memory randomly. I think he had some benchmark in one of these presentations showing that if you access every cell of a 1 gigabyte array and you access them sequentially, and you do the same thing with that array but access them randomly, so you access all the cells but you access them in a random order, then the speed difference was a 90x speed difference. So that's when I realized, okay, there's a lot of performance to gain from accessing data that is stored sequentially, and the same is true on disk.
I know that the disruptor was used, I think, in Log4j2 internally. I look at this as, okay, for my project is less interesting because the memory has to live somewhere, right? And if you are on application server or in the cloud, you have usually 2 clusters. It's not that easy to have something in memory which survives all the requests. So this is mostly interesting for high performance apps which run all the time in a kind of singleton. And I lived in complete different world. For me, there was no singletons. Actually, we're forbidden. We have no load balancers, always application servers. So, and for me, I'm also spent some time right now in AWS. And transition for application server to AWS was pretty easy because they are exactly the same concepts. Actually, we were not supposed to write from EGBs to a local store, and you shouldn't start threads and synchronization. And if you follow that, if you look at AWS Lambda or even Fargate, I mean, you're good, right? The only difference is everyone back then cursed and said, okay, enterprise Java is stupid, it's very restrictive. And now you say, okay, now we are in the cloud, so we have to be restrictive, right? So that's the only difference.
Yeah, no, I agree with you. When you do many of these traditional enterprise applications and with a lot of business logic in, most of the time you need horizontal scalability more than vertical scalability, right? So, and as soon as you have more than one application server, then the game changes. Right?
Yep.
Like you say, you cannot just store everything in memory anymore, and if you cannot, unless you use something like sticky session load balancing.
Yeah, but this is
maybe you can do
problematic.
And and this is, I guess, is almost impossible to do with the serverless, right? With lambdas, because you cannot control which lambda instance.
You could, but it was slower. You will have to access from lambda the elastic cache or something like this, but you will lose, the entire performance. You could do this, but this will be orders of magnitude slower than random access, I guess. Yeah. Also interesting. I think last year or this year, early this year or last year, I delivered either a keynote or session. And what I did is I compared EGBs to lambdas and tried to explain lambdas, AWS lambdas with EGB's programming model. And the interesting part, what happened then, I realized they're almost identical. If you think about this, we have also experience with EGBs, right? So we were concerned.
Especially the session beans, right?
Session bean, yeah. Session bean, because there was cold start time, so there was an init pool size, to prevent the cold startup, which mattered at the beginning of Java. Then we had the max pool size, which you could set, okay, it should not scale more than this, and the only difference is that the EJBs run in threads on an application server, and AWS Lambda runs in processes. Every thread is a process, so this is the main difference. But anything else is actually identical, which is also interesting. And I also, in my projects, I explained this to my developers, or my developers in my team, and they really like it. So they say, okay, you are right, actually. That it changes the entire perspective. So if you see it differently, Lambda seems like a toy, but if you look at this from this perspective, it is actually more powerful than anything else, because every Lambda can have up to 10 gigs of RAM and 6 CPUs if you like. So this is actually incredible, right? So, and if you would run a container, then you have 6 CPUs and 10 gigs inside a container. And in Lambda, you have the entire power per function invocation. So it is complete different. Yeah, interesting.
I definitely one of the most interesting technologies or like spaces of technologies on AWS is the whole serverless space.
Mhm.
I find that really interesting also with the serverless databases
Mhm.
and like serverless batch processing and all that stuff. So it just starts up when it's needed, and other than that, it's not running.
Exactly.
I think it's especially for like small startups or like big or like just companies that have workloads that don't have to run all the time and all that stuff. I think it's really an interesting technology, and then it can also scale to when you have a lot of workload and stuff like that. But then you get into new performance challenges such as the cold startup time, right?
What's interesting, so let's talk about AWS now, because what I spent my time the last 3 years is I'm migrating actually application servers to the cloud. And if I do it, it's okay, there should be added value. And if you look at the cloud, the only added value is, from my perspective, is serverless. Because, if you run the Kubernetes cluster once again in the cloud, there is no difference. It will be more expensive, but no added value. But with the serverless, what really changes the game is the invoice, right? Because the management, they see at the end of the month exactly how much money we spent for use cases actually. And this is really interesting. So this is for me, actually, this is the game changer, not necessarily, the scalability, because you mentioned that I scaled horizontally. It was not about scaling. It was always about high availability, for instance. So recently, there was the question what we do with static assets on AWS. And so of course, we store it in S3. But there was another idea to run Nginx. Okay, I don't get it. And even if we would run Nginx, we will actually have to run two Nginxes, because if one dies, then we are offline. And so we always had two instances, and one server scaled. I think for most enterprise applications, one server would be even better, because you could then apply your tricks with Disruptor, and you could cache stuff. If you have two application servers, it was actually worse. But we had to do this in some projects because of disaster recovery, right? So if the server dies, how long does it take to boot it? This was the only problem, right?
Yeah, and the Lambdas are just really, really great there, right? Because they just boot themselves when you need them.
Yeah. And now cold start time, because you mentioned that. And actually, I delivered yesterday an online session, and there was also a question. So what I did, I actually deployed in real time a Java application to AWS. And if you use microprofile with Jakarta E, so you have an app, with dependency injection, application scope, a few beans injected, and you deploy it with Micronaut or Quarkus. It boots around 2 seconds, the very first cold start. And subsequent invocations yesterday were 10 milliseconds. And if it is unrealistic, because this was Hello World, but if you do something more, it is with JSON, for instance, JSON B, JSON P without any optimizations. IC times 100 milliseconds response times for enterprise app is great.
Yeah.
But listen, with Lambda, the cool story is I don't have to care about VPCs and subnets and NAT gateways. It just runs without the overhead. And this is highly, I would say, underestimated how complex it can become, right? So set up an application load balancer with security groups and HTTP listeners and NAT gateways or whatever, and public and private subnet and CIDRs. It is fun, but with Lambda, such things doesn't exist. So I have to say, the serverless reminds me really about application servers.
Yeah. I think I just worked on a project where we also used a lot of Lambdas, and we also used various different. Amazon has a lot of different triggers that can trigger your Lambda.
Mm-hmm. What are asynchronous Lambdas you use, right? I use the behind HTTP API gateway mostly for migrations, and the triggers are the asynchronous Lambdas. So there are two kinds of Lambdas.
Yeah, and we used like triggers, like when a file was uploaded to S3, then that would trigger a Lambda that would then verify the files and see if all the files for a certain trip had been uploaded and all that stuff. So I like how Lambdas are also very well integrated into the entire AWS ecosystem.
Mm-hmm.
So it's easy to make something somewhere else trigger a Lambda.
Mm-hmm. But you are already one step ahead, because what you are talking about, all resources on AWS, they are emitting events. And you can subscribe to these events with Lambdas. So what I'm doing in the migration project is a step before. We just migrate the old Java code, Java E code, and package with Quarkus, and there's this exactly the same source code. And the Quarkus listens to HTTP API events, which are emitted by the HTTP API gateway or application load balancer. Both are working, or function URL. And for you, it's no difference. You can use, your old programming model with dependency injection. It looks like, so yesterday I showed the attendees old code. It was 12 years old, and without any modification, it could run us on AWS Lambda. And it's interesting. The only restriction is if you would like, to have a Lambda which is accessed privately. This is what hybrid clouds via direct connect. Then you have to run it in a VPC. But it's still simpler than the other options, because you only need the VPC and subnet and not the entire thing. Interesting. So I didn't expect it that you're also doing AWS these days a lot.
No, I haven't been talking much about it yet. I've been working with it working here for like 1.5 years, and part of the time I've also been doing some Java and Kafka consulting.
Okay. Of course.
Yeah. So it's not only AWS that I work with here, but it's mostly AWS, but also sometimes Java. Yeah. So it's a huge ecosystem to learn. I think this entire AWS platform. So, and I think if you come at it from a perspective where you have a specific workload to run, then it's maybe a little bit easier to focus in and learn just the things you need to run this workload. But we are an AWS consulting house, so every time we change clients, then the clients are using maybe some new AWS services. So there's a lot to learn in a very short time. So I haven't been writing much about it yet. I've been mostly just busy catching up.
I'm thinking about abstractions recently and then architecture. So on premise, you remember you also spent some time with Java. We spent a huge amount of time, abstracting from products, databases, message queues. So this was actually the main idea, because it's like, what happens when, the company switches from Oracle to DB2? Then we have rewrite everything is too expensive. Now, what I don't understand, so what many companies are doing, they are applying the same logic to clouds. And this costs a huge amount of money, because if you start, to abstract from the cloud, you don't have any benefits from the cloud. You are paying for the cloud, and you have to implement the abstractions. So what I actually doing in my projects, I'm fully using the cloud, and then the entire design is simple. But if you would have to migrate from AWS to Azure, usually it's not a huge problem, because if you compare, let's say, Fargate to ACI or Azure App Service, or if you compare AWS Lambda with Azure Function, they are very similar if you're not abstracting. So I think a developer could migrate this in a day without any problems. The huge problem with that, or where the problem is identity management is completely different, networking is different. So this is where is overlooked that actually this is the problem, not necessarily abstracting from the cloud specific services. And you mentioned Kafka. This is why I because I also do Kafka a lot. But in the cloud, for instance, if you have the choice, I would prefer Kinesis, for instance, for that reasons. Because Kinesis is serverless. There's also Kafka, serverless Kafka, but in Kinesis I say, here's the topic, and in 1 second later I have the topic. If you set up Kafka in the cloud, you wait 40 minutes for the managed Kafka, and the serverless Kafka is a bit expensive, I would say, right? So what I do, I have actually 2 architecture styles. They are complete opposite. So I behave different in the cloud and also on premise. So you see the point. So what's your idea? So what are your observations?
I completely agree with you with the sentiment that if you use the cloud and you try to abstract everything away, then first of all, you spend a lot of time working on these abstractions to get them to be good enough to represent both one cloud and the other cloud. And and you also risk ending up only being able to use the services or kinds of services that are present in more than one cloud. So I think if you want to have like a completely abstracted or like cloud independent architecture, you probably need to go with something more
Kubernetes,
more basic, like with virtual machines or Docker containers and Kubernetes and stuff like that, which is almost the same when you change to another cloud. But then you cannot easily use something like DynamoDB, for instance,
exactly,
or CosmosDB,
exactly,
and even though these databases might feel a little bit similar across different clouds, they are probably not entirely similar. And so I think personally, I am a little bit, I don't know how you say, torn between on the one side just saying, just choose a cloud and then you go all in on that cloud and like you can really get some, you can really do something very fast with the AWS and Lambdas and DynamoDB, right? And if you even just make your Lambdas in JavaScript or Python or something like that, then a lot of these single Lambda transaction style functions, they don't require that much business logic really. So they are maybe like 2-3 pages and that's it.
But it's cool. What you have to do, you have to measure. Java is faster than JavaScript. So if you run the Lambdas as Java or instead of JavaScript or Python, you will save 10 to 20%, which is actually a huge amount. Yeah. And on AWS, you are not using GraalVM. The Corretto is just fine because it optimizes, step by step the code, and works actually perfect. And for the infrastructure as code, we use CDK, so the Java part, which is very, very lean. And the cool story is you can combine this with Maven. So right, so what you can do is you can create your own construct, like Jakob's microservice, and you say add, and you are done. And behind the scenes, the entire magic happens. And in larger companies, we are we are deploying our custom constructs to Maven Nexus, and teams can reuse it. And this is actually, if you compare this with Terraform, let's say, with Terraform, you will have to write, orders of magnitude more code to achieve the same. So this is where I spend the time, and this really it's actually. It is not simple because you still have to understand the APIs. But if you know the APIs, it's very fast to write as a Java developer.
You mean the AWS APIs? Yeah,
the CDK, Cloud Development Kit from AWS. On Azure, I tend to use Bicep. This is a common language from Azure. But and in some projects, management decided to use Terraform with the hope that they are multi-cloud, which they are not, because the resources are so different on Azure, on AWS, that you cannot abstract it with Terraform. You can maybe you learn the syntax once, but this is all you got.
Yeah. As soon as you need to make a call to one service, then you will see that the interface is different.
Yeah, exactly.
From the different clouds and the way you represent identity and.
So which service are you using? You are spending your time with Fargate now?
No, my previous project was actually a mix of just lambdas written in Python, and then there were some Python applications that were running on virtual machines.
Okay.
And they were running in a batch environment, so we would submit batch jobs to a queue, and then Amazon Batch would start up these virtual machines whenever.
Was SQS, I guess, right? SQS or Kinesis.
Yeah, it was SQS, and then that would trigger the startup of the batch environment.
Mm-hmm. What is the cold start with Python?
The cold start with Python is not very high, but it's under 100 milliseconds. But what I have seen from several of these people that are measuring these cold startup times is that it depends a lot on the size of the application. You can get Java to have a cold start of, I think, is it like less than 500 milliseconds if you do not have a lot of, if your code base is very small.
Yes.
So if you use a big framework like Spring or something like that, then obviously that increases your cold start time. But if you have only exactly the code you need, you only use Amazon's own APIs, and you just have a few Java classes that do exactly what you need them to do for that particular Lambda, then you can get it below 500 milliseconds.
And the trick is, if you use Micronaut or Quarkus, they even optimize further. So you could have, our old programming model, and what Quarkus and Micronaut are doing, they are dropping out reflection. There are no class loaders. They optimize the bytecode, so it starts really fast.
Okay, that's pretty cool. And I've also seen people compile their applications to native, and then the cold startup time is also reduced quite a lot.
And if you don't like startup, you can always run, with provision concurrency. So you're paying $15 a month.
That's true.
But and then you have never ever a cold start for one Lambda. And what's interesting is, if you do this with provision concurrency, all the codes become a little bit cheaper. So if you have a lot of traffic going on, maybe you will even save money.
Okay, I wasn't aware of how big a difference it makes to run in practice with that switched on.
Cool. So Jakob, it was really nice to meet you. So the first time we met after 25 years of Java. So it's amazing. We look like 15, right? And we still have Java experience. Where people can hire you? I mean, if someone offers you a huge amount of money, you will still become freelancer immediately, right? I guess. So I think your website is jenkov.com.
That's true. Jenkov.com or
JENKOV.com. Yes.
.com, yeah. I'm not sure if there are any contact details directly in there, but otherwise, I guess the easiest way would be to find me on Twitter or LinkedIn.
Yeah. What is Twitter? What is your Twitter handle?
It's just at jjenkov.
Okay.
And I guess in LinkedIn, I guess you can just search for my name. I guess I will show up somewhere in there.
Cool. So it was a pleasure.
Yeah, it was very nice to talk to you too. This is actually I kind of miss having some talks like this where we just have time to hear what people have been doing and like people's interest and all that stuff. We should.
I can re-invite you back, and we can have a chat, about AWS, your experiences. So this is also interesting for me what you are doing. So
that would be cool.
We do it. So cool. Next year we schedule another meeting and have a talk about AWS. Perfect.
Okay, perfect. Thank you.